Hey guys, welcome back to the live stream. I just want to apologize for the audio issues that we had a couple minutes ago. Hopefully everything is worked out this time. And I just want to say welcome everyone from all over the world. Thank you so much for joining us, for joining me. And it's an honor just to be able to teach you guys all over the world. And Oki124, welcome back. Let me know how the audio is and if I need to turn up or turn down the volume. But hopefully this time it's better. We're going to be going over completing the square today, and I'm going to create a lesson where we can solve quadratic equations by completing the square. And I want to start off by saying that if you guys need any extra help with any other types of problems, I do offer homework solutions on my website. So check out my website or send me an email to homeworksolutions@mathmeeting.com. And it's not free like this lesson is for you guys, but I am able to help you whenever you want. So send me an email if you need any extra help to homeworksolutions@mathmeeting.com, or if you want any problems for me to work on during this live stream, send me an email to LiveStream@mathmeeting.com. But the live stream is once a week, and the homework solutions, I can help you out whenever you want. So I just want to let you guys know about that. But today, during this live stream, we're going to be talking about completing the square. And I'll start by saying that by completing the square is only something you should do if your teacher forces you, or if the directions say you have to solve a quadratic equation by completing the square. Otherwise, use the quadratic formula. Let me write that down for you. Use the quadratic formula. Use the quadratic formula anytime you need to solve a quadratic equation, or you could use factoring. Factoring is even quicker than using the quadratic formula. Only use completing the square if the directions tell you that you have to use this method. Otherwise, use other methods that are much quicker and much shorter. So let's get started right away with this first example. It says solve this quadratic equation by completing the square. So notice in our directions that it says that we have to solve by completing the square. All right, so we don't have a choice. We have to use the completing the square method. And the first step in the completing the square is getting rid of a constant in front of this x squared term. Notice how we don't have any constant, or there's a constant of 1 already in front of this x squared, so that's good. We can skip step number 1. But normally you have to get rid of any constant that's in front of this x squared term. All right, and after we do step number 1, then our next step is to get rid of this constant on the left-hand side, and we want to bring it to the right-hand side of the equation. And in order to do that, we need to subtract both sides by 15. So I'm going to subtract 15. So notice on the left-hand side, the positive 15 and the negative 15 cancel each other out. And whatever you do to one side, you have to do to the other. So we have to subtract the right side by 15 as well. All right. So now on the left-hand side of the equation, we just have x squared minus 8x. And on the right side, we just have 0 minus 15, which is just equal to negative 15. All right, so we completed step number 2. We got rid of the constant and we brought it to the right-hand side of the equation. So now step number 3 is to add b over 2 squared to both sides of the equation. Whatever you do to one side of the equation, you have to do to the other. So since we added b over 2 squared to the left side, we also have to add b over 2 squared to the right side of the equation as well. All right. And let me know how the video settings are. How's the quality, and if it's buffering too much, or if it's too slow, I can change the settings so the quality is a little better. So use the chat and let me know how the video quality for this video is. All right, so moving on to our next step, we just added b over 2 squared to both sides, all right? And our b is always going to be the constant in front of the x term. So we have a negative 8 as our b, okay? So what we're going to do, instead of b over 2 squared, I'm going to plug in a negative 8 for b. And I'm also going to plug in a negative 8 for b on the right-hand side as well. And the rest of the equation is going to stay the same. We have x squared minus 8x. And this is equal, we have a negative 15 plus negative 8 over 2 squared. All right. So at this point, we just have to simplify this as much as possible. On the left-hand side, we have x squared minus 8x plus negative 8 over 2, which is a negative 4. Negative 4 squared is going to be a positive 16. So this is equal to positive 16. And on the right-hand side, we have a negative 15 in red. So we have negative 15. And then we know in green, we have negative 8 over 2 squared, which is equal to positive 16. So this is a positive 16 as well. All right, so at this point, let's keep on simplifying this even further. The reason why we added this negative b over 2 squared is to make this a perfect square. At this point, now we know that the left-hand side of the equation is going to be a perfect square. This x squared minus 8x plus 16 is going to factor into a perfect square. And we know that we're going to have an x as our first term. Our second term is always going to be half of our b, so half of negative 8 is equal to negative 4. And we square it. Okay, and if you FOIL x minus 4 squared, you're going to get x squared minus 8x plus 16. So that's the reason why we added this positive 16 here, so we can create this perfect square. All right, and on the right-hand side, we have negative 15 plus 16, which is equal to positive 1. All right, so now if we keep on moving on, we can solve for x by getting rid of this square right here. All right, so if we get rid of the square, then we can solve for x. So how do we get rid of a square? You can get rid of a square by square rooting both sides. So let's square root both sides of this equation. And whenever you square root both sides of the equation, on the right-hand side, make sure you put a plus or minus. And this is because if you square a negative number, it's also going to be positive. Okay, so you can't forget to put a plus or minus on the right-hand side of the equation. So at this point, since we squared a square root on the left-hand side, the only thing we are left with is x minus 4. The square root and the square cancel each other out. And on the right-hand side, we have plus or minus the square root of 1. The square root of 1 is just equal to 1. So we have just plus or minus 1. All right. So now we just need to keep solving for x. So we need to get rid of this negative 4. All right, so to get rid of a negative 4, we can add both sides by positive 4. All right, so if we add both sides by positive 4, on the left-hand side, the negative 4 and the positive 4 cancel each other out. All right, so on the left-hand side, the only thing we're left with is x. And we have plus or minus 1 plus 4 on the right-hand side. All right, so we have a positive 1 plus 4, which is equal to 5. And we have a negative 1 plus 4, which is equal to 3. So x is equal to 5 or 3. There are two solutions to this problem. All right, so we have officially solved this quadratic equation by completing the square. X is equal to positive 5 or positive 3. Please let me know if you guys have any questions on this problem. Let me know if you guys didn't understand any of the steps that I went over, and I would love to help you out. Use the chat whenever you have a question, and I will make sure that I answer it for you. So this is the solution to our first problem. X is equal to 5 or 3. This is as easy as it's going to get. So all the next problems we are going to also be completing the square, but they're going to be a little bit harder as well. So let's move on to our next problem. Our next problem is solve this quadratic equation by completing the square. It's 4x squared plus 8x minus 9. All right, and we have to solve this by completing the square because they tell us to. We have to complete the square. Otherwise, use the quadratic formula or factor. Any other method is quicker than this. All right, and before I get started with this problem, if you guys have need any extra help, check out my website at send me an email to homeworksolutions@mathmeeting.com, and with any problem that you need help with, or any problems that you need help with, I should say, I will give you a quote based on how much time it'll take me to solve these problems, and I would love to solve them for you. So unfortunately, it's not free like this live stream is, but you can get help from me any time of the week. So let's go back to our original problem. So we have 4x squared plus 8x minus 9 is equal to 0. We need to solve this by completing the square. So step number 1 is we need to get rid of this constant in front of the x squared term. So this why this one's a little bit more complicated than our last problem. Our last problem, we did not have a constant in front of our x squared. Okay, notice how our x squared was already by itself. So this one's a little bit more complicated because we do have this constant of positive 4 in front of our x squared. And so at this point, we just need to get rid of this constant. So we can do that by dividing both sides of the equation by 4. And by dividing both sides of the equation by 4, notice how this constant in front of the x squared cancels out. And the only thing that we're left with is x squared. And the rest of our equation, we have positive 8 over 4, which is equal to 2 in front of our x. Then we have a negative 9 over 4. And on the right-hand side, we have 0 over 4, which is equal to 0. All right. So at this point, we need to go on to step number 2. Step number 2 is to get rid of this constant on the right-hand side of the equation. All right, so we always need to bring the constant to the right-hand side of the equation. So we have a negative 9 over 4. To get rid of it, we need to do the opposite. So we need to add both sides by 9 over 4. And by doing this, the negative 9 over 4 and the positive 9 over 4 cancel each other out. And we got rid of our constant on the left-hand side, and we brought it to the right-hand side. Okay. So now the left-hand side of the equation stays exactly the same. We have x squared plus 2x. And on the right-hand side of the equation, we have 0 plus 9 over 4, which is just 9 over 4. Okay, so now we have just completed step number 2. Now we need to move on to step number 3. Step number 3 is to add b over 2 squared to both sides of the equation. We need to add b over 2 squared to both sides of the equation. Why do we do this? We add b over 2 squared to both sides of the equation to make a perfect square. This will eventually make this left-hand side of the equation a perfect square. Okay, and that's the whole idea, is to make the left-hand side of the equation a perfect square. So that's the only reason why we added b over 2 squared to both sides. All right, so we know that our b is equal to positive 2. So I'm going to erase b and plug in a positive 2 in for b. So I'm going to erase b on both sides, and I'm going to plug in a positive 2 instead. Once again, our b term is always the constant in front of x. All right, So now if we simplify this even further, on the left-hand side, we have x squared plus 2x. And then we have 2 over 2, which is equal to 1. And 1 squared is just equal to 1. So our term in green is just equal to 1. All right, and we know that on the right-hand side, it's exactly the same. 2 over 2 squared is equal to 1. All right, and we can't forget that we have our 9 over 4 in red as well. Okay, so now at this point, we have created a perfect square on the left-hand side of our equation. So this is good. We're getting close to solving this. All right, and once again, once you create a perfect square, you know your first term is going to be x. Your second term is always half of your b. Half of positive 2 is equal to positive 1. And then we square it. And on the right-hand side, we have 9 over 4 plus 1. Okay, and if you distribute or FOIL the left-hand side of the equation, it's going to be exactly the same as what we started with. So we haven't changed anything one bit. All right, so now at this point, step number 4, we need to solve for x. So in order to solve for x, we need to get rid of this squared symbol. All right, so to get rid of a square, we're going to square root both sides. And before I do this, actually, I'm going to simplify the right-hand side of the equation. Okay, I'm going to rewrite 1 as a positive 4 over 4. 4 over 4 is exactly the same as 1. And the reason why I did that is so I can create common denominators. So now we have a common denominator, and we can add these two fractions really easily. All right. So when you add fractions, the denominator stays the same. So on the right-hand side, we're going to have on the right-hand side of the equation, our denominator is the same. So we're going to have a 4. And in the numerator, we're going to have 9 plus 4. 9 plus 4 is equal to 13. All right, and our left side of our equation stays exactly the same. All right, and let me just get the right color here. Go back to black. So we have x plus 1 squared on the left-hand side of the equation. All right, so now at this point, we need to solve for x. So to solve for x, we need to get rid of this squared symbol. So to get rid of the squared symbol, I'm going to square root both sides. Square root both sides of this equation. On the left-hand side, the square and the square root cancel each other out, so the only thing we're left with is x plus 1. And on the right-hand side, we have plus or minus. We can't forget that we need to put a plus or minus on the right-hand side. So we have a plus or minus square root of 13 divided by the square root of 4. The square root of 13 over the square root of 4 is exactly the same as the square root of 13 over 4. And the reason why I did this is so we can simplify the bottom. The square root of 4 is equal to 2. All right, so I'm going to rewrite the square root of 4 as a positive 2. All right, and we're almost finished with this problem. We need to subtract 1 from both sides of the equation. And the reason why we're doing this is to get x by itself. So by subtracting 1 on the left, the positive 1 and the negative 1 cancel each other out. And we also have to subtract 1 from the right-hand side of the equation as well. All right. And so now we have solved for x. On the left-hand side, the only thing we have left is x. And on the right-hand side, we have plus or minus the square root of 13 over 2 minus 1. All right. And that is the solution to our problem. X is equal to plus or minus the square root of 13 over 2 minus 1. And notice how this was a little bit more complicated. First, because we didn't have, we had a constant of 4 in front of our x squared term, which we had to get rid of. Plus we had some fractions in our problem as well, which made it a little bit more complicated. So that is why I wanted to go over an example like this, just to give you an idea of how hard these problems can get. But the idea is exactly the same. You just need to follow all of the steps that I'm telling you, and you can solve the equations by completing the square. So x is equal to plus or minus square root of 13 over 2 minus 1. All right. And let me know if you guys have any questions on this problem. Someone said send him a donation. I don't expect any donations from you guys, but if you guys do want to use the super chat and and send a donation, I would be very appreciative of that, and I would be very thankful. So, but I do not expect that from you guys. I'm doing this because I love to teach, and it's an honor just to be able to teach you guys all over the world, and I love doing it. So let me know if you guys have any questions over the last problem that we just went over, and I will get started on the next one. All right, it says solve by completing the square. And the reason why this one is a little bit different than the problems we did before is that we have a negative term or a negative sign in front of our x squared. And because we have this negative sign in front of our x squared, we need to change it so it's a positive x squared. All right, and you can imagine that there is a 1 in front of this x squared. You can say that there's a negative 1 x squared. That doesn't change it one bit. So in order to get rid of this negative 1 in front of our x squared, I'm going to divide the left-hand side of the equation by negative 1 and the right-hand side of the equation by negative 1. All right. Once again, you can imagine that there is a negative 1 in front of this x squared term. Okay, so now by doing this, notice on the left-hand side of the equation, the negative 1 and the negative 1 cancel each other out, and the only thing we're left with is just x squared. So now we've got rid of that constant in front of our x squared, and now we can move on to step number 2. So we have x squared, negative 8 over negative 1 is equal to positive 8, so now we'll have a positive 8x. Positive 16 over negative 1 is equal to negative 16. And on the right-hand side, we have 0 over negative 1, which is just equal to 0. All right. So now at this point, we need to add our constant of 16 to both sides. We need to bring the constant to the right-hand side of the equation, and this is step number 2. So in order to bring that constant to the right-hand side, we need to get rid of this negative 16 by adding 16 to both sides of the equation. All right, and notice how the negative 16 and the positive 16 cancel each other out. And on the left side, we're just left with x squared plus 8x. So we have x squared plus 8x on the left-hand side. And on the right-hand side, we have 0 plus 16, all right? So 0 plus 16 is equal to positive 16. And we have just completed step number 2. All right, step number 3 is exactly the same. You guys are probably should have this memorized by now. Step number 3 is to add b over 2 squared to both sides. So I'm going to add b over 2 squared to both sides of this equation. All right. And once again, our b term is always the constant in front of x. So we have a b of positive 8. Okay. So I'm going to erase our b's and replace them with a positive 8. The b is always our term in front of or the constant in front of our x term. All right, so I'll replace b with a positive 8 on the left and the right-hand side. And now we can simplify this even further. We have x squared plus 8x. And in green, we have 8 over 2, which is 4. 4 squared is equal to 16. So in green, we have a positive 16. Once again, 8 over 2 is 4. 4 squared is equal to positive 16 on the right-hand side as well. And then we still have our 16 in red. Okay, so notice on the right-hand side, we have 16 plus 16, which is equal to 32. And notice on the right-hand side, we have a perfect square. X squared plus 8x plus 16. Because we have a perfect square, we know that we can rewrite it with an x as our first term, and our second term is always half of b. Half of 8 is equal to positive 4, and we need to square it. And I'm running out of space here, so let me just move this down a little bit. Okay, so now at this point, we just need to solve for x. So in order to solve for x, we need to get rid of this squared term. To get rid of a squared term, we need to square root both sides. And once again, if you square root a squared term, you need to plus or minus the right-hand side of the equation. All right, on the left-hand side, the square and the square root cancel each other out, so we're left with x plus 4. And on the right-hand side, we have plus or minus the square root of 32. All right. And now the reason why I chose this problem is because the square root of 32 is and can be simplified even further. Okay, we can simplify this radical. All right, so every time that you can simplify a radical, you always want to try and simplify it as much as possible. The reason why this can be simplified is because the square root of 32 can be rewritten as the square root of 16 times the square root of 2. Okay, 16 times 2 is equal to 32. Okay, and the square root of 16 is equal to 4. Okay, the square root of 16 is equal to 4. So this can be equal to plus or minus 4. And we can't forget that this is being multiplied by the square root of 2. Okay, and once again, the square root of 16 is equal to 4. That's where this 4 in blue is coming from. All right, and the left-hand side of the equation stays exactly the same. We have x plus 4 on the left-hand side of our equation. All right, so we have x plus 4 is equal to plus or minus 4 times the square root of 2. All right, so now we need to subtract 4 from both sides of the equation so we can solve for x. Notice how the positive 4 and negative 4 cancel each other out. And the idea is to get x by itself, so that's why I'm doing all these steps. So now we do have x by itself, and on the right-hand side we have plus or minus 4 times the square root of 2. So we have plus or minus 4 times the square root of 2 minus 4. All right, and this actually can be simplified even further. We could actually factor this. Notice how both of these terms have a 4 in common. All right, because they have a 4 in common, we can factor this even further. But just for to save some time, I'm not going to show you guys how to factor this, but you can factor out a 4 if you want. It'd be plus or minus 4 times the square root of 2 minus 1. So this is the solution to our problem. And I just want to go over one more problem that's really cool. And let me know if you guys have any questions on this problem. And I would love to try and help you out as much as possible. And I'll take this time to let you guys know that if you guys have any questions on any other problems, whether it's calculus or algebra, doesn't matter what it is, send all your questions to homeworksolutions@mathmeeting.com, and I can help you out any time of the week. Unfortunately, it's not free like this live stream is, but you can get help anytime you want. All you have to do is send pictures of all the problems to homeworksolutions@mathmeeting.com, and I would love to help you out. So let's go over the last problem for this live stream. And here we have the standard form of a quadratic equation. We have ax squared plus bx plus c. And it says prove the quadratic formula. And we're going to prove the quadratic formula by actually completing the square. We're going to do this, use the same exact steps to prove the quadratic formula. All right, and the quadratic formula, just to let you guys know, the quadratic formula is equal to x. If you have the standard form of equation, the quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4 times ac all over 2a. Okay? So we're going to prove this formula to be true by completing this square of this generic quadratic equation. So I'm hoping that you guys find this as fascinating as I do, because you actually can prove this quadratic formula by completing the square. So we're going to use exactly the same steps that we used for all the rest of the problems to prove this formula. So I think that's pretty cool. So let's get started right away. So what is our step number 1 for completing the square? Step number 1 is getting rid of the constant in front of the x squared term. So our constant of a, we need to get rid of this. So we're going to divide both sides of this equation by a. All right. And notice how the a's cancel each other out in front of the x squared term. So the only thing we're left with is x squared. Sorry, change to color black. So let me change this color really quick. All right, so we have the a's cancel each other out. So in front of the x squared term, we just have x squared. Then we have b over a times x plus c over a. And on the right-hand side, we have 0 over a, which is just equal to 0. All right. So now we need to move on to step number 2, because we got rid of this constant in front of the x squared term. So now if we get rid of this constant of c over a, we're going to bring it over to the right-hand side of the equation, which is what our step number 2 is. So to get rid of it, I'm going to subtract c over a from both sides of the equation. And on the left-hand side, the positive c over a and the negative c over a cancel each other out. All right. So what we're left with, let's simplify this. On the left-hand side, we have x squared plus b over a. So we have x squared plus b over a x on the left-hand side. And on the right-hand side, we have negative c over a. All right. So now we just completed step number 2. Our step number 3 is to add b over 2 squared to both sides. So let's add b over 2 squared to both sides of the equation, and then we'll have a perfect square by doing this. Okay. And notice how by doing this, we have our b term is going to be equal to b over a, okay? notice how in front of our x we have a b over a. This is actually going to be our b term. Okay, the constant in front of x is always our b term. So if I erase b on the left and the right hand side, I'm going to erase b. I can replace it with b over a. Okay. So notice how we have a fraction within a fraction. So we have b over a divided by 2. All right, so let's simplify this even further. So b over a divided by 2 is just equal to b over 2a. All right, so b over a divided by 2 is equal to b over 2a. And everything else is going to stay exactly the same. So we have x squared plus b over a x, and that's equal to negative c over a. All right. So now I'm going to simplify this b over 2a squared in blue. All right. So let's simplify this b over 2a squared in blue. If we square the numerator and the denominator, in the numerator we're going to have b squared, and in the denominator we're going to have 4a squared. All right, and the right hand side it's exactly the same. So on the right hand side we're going to have b squared, and then the denominator we're going to have 4a squared. And once again I just squared the numerator and I squared the denominator for both terms. Okay. So if we do that, we have b squared over 4a squared, and the rest of the equation is going to stay exactly the same. So we have x squared plus b over ax, and we also have our negative c over a. All right. So sorry about that. All right, it's looking kind of complicated at the moment, but I promise you that it's going to look a little more, it's going to make all sense once we figure this out. Notice here on the right-hand side that the negative c over a and the b squared over 4a, these are two constants. So we can actually add these two constants together. But in order to do this, they need to have a common denominator. All right, and they don't. This one has an a in the denominator, and this one has a 4a squared in the denominator. So I'm going to multiply both the numerator and the denominator of this fraction. So I'm going to multiply the denominator by 4a, and I'm going to multiply the numerator by 4a as well. Sorry, my work's a little sloppy. And the reason why I did that is so we can have common denominators. So this is going to equal to 4ac over 4a squared. And on the right hand side, we still have our b squared over 4a squared. And the right side of our equation is going to stay exactly the same. We still have, sorry, the left hand side, our x squared plus b over ax plus b squared over 4a squared. Okay. So now I'm running out of space here, so hopefully we can finish this soon. All right, now on the left-hand side, let's notice how we have common denominators now, 4a squared. So since we have common denominators, we know that in the denominator, we're going to have a 4a squared. And in the numerator, we have 4ac plus b squared. All right, so we have 4ac plus b squared in the numerator. And the left-hand side stays exactly the same. So we have x squared plus b over ax plus b squared over 4a squared. All right, and I'm just going to zoom out here so I can give myself more space. I'm going to erase a lot of the steps here. All right, and I'll drag this up just to give myself a little bit more space here. All right, I'll zoom back in. Okay, so we have x squared plus b over ax plus b squared over 4a squared is equal to 4ac plus b squared all over 4a squared. And this is really a lot more complicated than, this is just a much more complicated problem, but I think it's fascinating just proving the quadratic formula by completing the square. So let's keep on working this out. Over here we have a perfect square. Okay, so we can factor this since we do have a perfect square. Our first term is going to be x, and our second term is always half of b over a, so half of b over a is b over 2a. And then we need to square this, and on the right-hand side, we have 4ac plus b squared all over 4a squared. That stays exactly the same. All right, so let's square root both sides to get rid of this, to solve for x, to get rid of this square sign. So I'm going to square root both sides, square root both sides. So if we square root both sides, what we're going to get on the right-hand side, we're going to have x plus b over 2a. The square root and the square and the square root cancel each other out. And on the right side, we're going to have a plus or minus, okay, the square root of 4ac plus b squared all over the square root of 4a squared. Okay, and the reason why I did this is because the 4a squared can be simplified. All right, because the 4a squared can be simplified, that's why I separated the square roots for the numerator and the denominator. So I haven't changed anything. The square root of 4a squared is actually equal to 2a. The square root of 4 is equal to 2, and the square root of a squared is just equal to a. So we can erase the square root of 4a squared, and we can rewrite this as 2a instead. All right, so we have 2a in the bottom. All right, and we're getting close here, guys. So now at this step, or at this point, we need to solve for x. So we need to get rid of this positive b over 2a term on the left-hand side. So I'm going to subtract b over 2a. So I'm going to subtract b over 2a from both sides. On the left-hand side, they're going to cancel out. And I'm also going to subtract b over 2a from the right-hand side. So we're going to have negative b over 2a from the right-hand side as well. And we are left with x on the left-hand side of our equation. On the right-hand side, we have negative b over 2a. So we have negative b over 2a. And then we also have a plus or minus square root of 4ac plus b squared all over 2a. Okay, and notice how we have a common denominator. We have a 2a and a 2a, so we can actually add these two fractions together because we do have a common denominator. Okay, so I'm going to erase our step before this so I can have a little bit more space. So I'm going to erase this up here. And on the left-hand side, we have x, And on the right-hand side, we have a common denominator of 2a. Since we have a common denominator of 2a, then we know that 2a is going to be in the bottom. And in the numerator, we have negative b. So we have negative b, and we have a plus or minus the square root of b squared plus 4ac. Okay, and I switched the 4ac and the b squared, because when you're adding stuff, you can switch them. It doesn't change it a bit. Okay, and notice how this looks like the quadratic formula, doesn't it? We have x is equal to negative b plus or minus b squared 4ac all over 2a. All right, so this is the quadratic, and this is the quadratic formula. So we use completing the square to solve, to prove the quadratic formula, which I think is pretty cool, and that's why I wanted to show you guys this. So if you guys have any questions, please let me know, and I will, and I would love to help you out help you out even more. So thank you guys so much for joining. I want to let you guys know that if you want any extra help, please send me all the problems you need help with to homeworksolutions@mathmeeting.com, and I would love to help you out any time of the week that you need help. You can just send me your questions to homeworksolutions@mathmeeting.com. Unfortunately, once again, it's not free like this live stream is, but I would love to help you out whenever you're, if I could. Also, if you guys have any suggestions for problems you want me to go over on the live stream, send me all of your suggestions to livestream@mathmeeting.com. And I just want to give a shout out to everybody who joined us today. Brent Grubbs from New York or from Pennsylvania, Kay Queen from New York. Thank you so much for joining us today. Thank you guys from all over the world for joining us. This was an honor just to be able to help you guys and to teach you guys all over the world using this YouTube. Thank you so much for watching, and I will see you on my next live stream.